Hi everybody, welcome to Test 1 review for Math 2413. On the top you see the list of the topics, and on that side you we will have the formulas that we'll be using. Right, let's go to the first one, finding limits for given graph. So we have the first and the second problem. So the first one, the limit of the function when x goes to -1. So we see that on the left side the function go to when x goes to -1, y goes to that would be 3, and on the right side when x gets close to -1, y will go to the same point. So that will be the limit. It will approach to this point, so we say the limit equal to 3. So when both sides goes to the same point, that will be the limit. Right. I'll go to the second one. So also the limit of the function when x goes to -1 from the left and from the right. So first, when x goes to 1, -1 from the left. So on the left of this side, if we go along the graph of the function, it will go to this point. So I should say it goes to that point. So we say the limit of the function when x goes to -1 from the left equal to -2. And the limit from the right will be on this side of -1. It goes to this point. So we say the limit when x goes to -1 from the right equal to, that will be -7. The y value is -7. Right. So the left side is -2, the right side is -7. Because of that, we say the limit does not exist, because the left and the right side. Right. The question asks for the left and from the right. But we can also say the limit when x goes to -1 of the function does not exist. Although the question did not ask us this question, did not ask that, but we can say the limit did not exist because the left and the right side do not agree. On this problem, both of the limits go to the same point, so the limit exists. This one doesn't. Right. But once again, the question only asks for the left side and the right side for the limit. Right. So that was 1 and 2. Right. Next, we'll go to number 3, where we find the limit using the table or numerically. This will use the calculator. So that's right. So let's move the calculator. Now just keep it that side. So this is the problem. So we just need to evaluate the function at those values, right? So we turn on the calculator. y equal to, I will enter the function x minus 4 divided by x squared minus 5x plus 4. Right. Once we're done, we can hit the graph on a lot of things, but this we want the value, so we hit second and trace, or we calculate and we choose the first option, so I just hit 1. Right, it will graph the function and then we enter the values of the function. 3.9, so we hit 3.9, hit enter, and we have 3.3448. So let's take the 3 decimal places, 348, and then next 3.99, we just keep this screen, do not do anything, we just hit the new number 3.99.334, and then 3.999.333, and we do the same thing for the other side, 4.001, 4.01, and 4.1. Just hit the number for x, hit enter, and we have the y values, 0.323. So now we complete the table, but the question is this one, the limit of the function when x goes to 4. 4 would be right in the middle here. Because of that, it is 0.333. So that would be 0.33. And this one just say that we estimate the limit. So it is equal to that. If we want the actual values, we can take this number approaching, so that we 0.3333, and that is 1 over 3. But this one we just estimate the limit. So we say the limit when x goes to 4 is about that. So it's good enough. Right. Let me update the list. Yeah, that's better. Right. As we finish the topic, I will draw the line across it. But we still need to read it. Anyway. Right. So that was 3. Next, 5 limit for the function. So let's look at number 4. Also, the first thing when we try to find the limit is just put in the number. So we put in 0, and that gives us 8 over negative 2. So that is equal to negative 4. If this is, oh sorry, we don't need the calculator anymore. Right. So it's number 4, and put 0 in for it, and we have that. So if it is a nice number, if it is defined, then that will be the limit. Later on, we know that this function is continuous and is defined at the same I mean, it is continuous whenever it is defined. So we just say the limit equal to that. Right. I'll skip that for a moment. This is one-sided limit for the next topic. So 4 and goes to 6. 6 will do the same thing. Put 6 in here. And that will be 36, 24, and 60. So we have 0 over 0. And 0 over 0 is indeterminate. And so that is not the answer. So we do not write the equal sign. If it is equal to a nice number, we make it equal to. If it is not, just try something else. Right. Now we do know that because we have 0 when x equal to 6 on the top and 0 when x equal to 6 at the bottom. So we have x minus 6 is the common factor. So this is the fact. Let me write it out. If f of a equal to 0, then x minus a is the factor. So we use this fact. Right. So both of them will have x minus 6 because the value is equal to 0 when x equal to 6. So we're going to have x minus 6 top and bottom. Right. And then to get to negative 60, we need to have a plus 10. Right. At the bottom, that's good. So we don't need to do anything. Now, cancel this out. We just have x plus 10. And then we put 6 in for x. And that is 16, which is a nice number. So we make that equal to 16. And that will be the limit. Right. Notice 0, 0 is indeterminate. Then they will have the common factor. That will be the same for the next one. But indirectly. Right, that was 4, 6. And now we go to 7. Right, we try the same thing. Put 4 in for x. And still the same thing. 0 over 0, which is also indeterminate. So we could do the same thing, but the factoring is a bit more complicated. So what we use is the conjugate. And we have a minus b times a plus b is a squared minus b squared. Actually, a minus b and a plus b are conjugate, or this is just the difference of two squares. So we have a minus b and a plus b, right? So that's what we have. Now, So what we do is we multiply top and bottom by the conjugate. This has minus, so we will do the plus. We can use the formula, or we just multiply it out. I'll just multiply it out. So square root of x times square root of x, that is an x. Square root of x times 2 square root of x minus 2 square root of x minus 4. At the bottom, I will not multiply it out because similar to the first, to number 6, we're going to have the common factor of x minus 8, which is x minus 4. So I know it's going to be a common factor of x minus 4, so we don't need to multiply it out. So just keep it like this. Right. The middle terms cancel out. Well, we just have a square minus a square. So we'll have x minus 4 on the top. And we cancel that. And then we put 4 into x. We have 1 over square root of 4 plus 2, which is 1 over 4. That is a nice number, so that will be the limit. Alright. So let me update the list. Right. Next we'll go to one-side limits. One-side limit. Right. For one-sided limit, we have 5, 8, and 9. I will do the 5 and of course we're not going to go over every problem here. We just sum of the problem. Let's look at 5. Right, for 5, limit of x of the function when x go to 2 from the negative sign. So we have 2 from the left side. If it goes to 2 from the left side, it is going to be less than 2. So we have to use the function, this function. So we'll have a limit when x goes to 2 from the left of the function will be equal to the limit when x goes to 2 from the left of negative 2x minus 7. Right, now we just put 2 into it. And that will be negative 11. And that is the nice number, so we make the limit equal to that. Right. Of course, when it is the numbers and it's not 0, then we don't have to worry about the plus or the minus. Even though we have a negative from the left side here, we don't really evaluate that. If it is 0, then we have to worry about it. It will come later. But now we just have that. Right. Now we go to number 9. Right. So of course when we evaluate, the first thing is we substitute in, but let's just rewrite x goes to negative pi over 2 from the left. Secant is 1 over cosine. Right. Now we evaluate. We're going to put negative pi over 2 into it. Again, calculator. Right. Cosine of negative pi over 2. That is, we're going to use the calculator later. So now, so make sure it is in radian mode. So it's good. Cosine negative. Difficult to see here, I think. Right there. Let me change this real quick. Trying to change the color. That's easy to see. Yeah, I think that better. Yeah. Right, that is 0, of course, we know that. Right, now, but this is just run 1 over 0. Of course, that is not going to be undefined. It is undefined, but by the way, that is number 9, right? Right. Next, if it is 0, then we really need to know if it is a plus or a minus. Now it goes from the left side. So now we just write it is negative pi over 2, and it is on the left of it. So it's going to be less than negative pi over 2. So this is what we're going to do. We're going to go with cosine of negative pi over 2. Sorry. Negative second pi divided by 2. Alright. Now we know that it's going to be less than it. So it's going to be, we just need to minus a very small number. Something like that. Oh. Not that. Yeah. Yeah. So because it goes from the left, so we just subtract a very small number to it, and now we will calculate, and that is a negative number. So if it goes from the left, it will be negative, and 1 divided by 0 is 0 by infinity, but it has negative, so it will be negative infinity. It will be B. Right. So let me write this down. When we have something that is not equal to 0 divided by something that goes to 0 on the plus or the minus sign, it will be plus or minus infinity. It could be positive or negative infinity, depends on whether we divide the positive by the negative number. Like in this case, it will be negative. although the sign is determined by when we divide, or we could be able to see that. In this case, positive divided by negative is negative, so we have negative infinity. Right, so that was 9. Right. Right. Yeah, that was 9. Right, next. Limits at infinity. Right. So I will look at 11 and 13. Right. So 11. So from the previous problem we have this, that formula. Now when we have infinity, there will be something similar to it. So we have, let me just write this down. Sometimes it is not infinity, so we just write finite divided by something that goes to plus or minus infinity. That will be equal to 0. So right. Now we do the problem 11. So now we say that x goes to infinity. As x goes to infinity, the highest power, only the highest power matters. So let me write that another fact. As x goes to plus or minus infinity, only the highest power matters. So in this case, we will have, let's just rewrite that. By rewrite, I mean x, square root of x, and write that x to the 1/2. And the formula that we use is this one. Right, so we will have the highest power will be this one. X to the 1/2 is higher than x to the negative 1. So 1/2 is bigger than negative 1. So we just take the 1/2 and negative 5x. Right. Now we will simplify. Negative 3, negative 5, that will be 3 over 5. Next, when we divide two power with the same base, we subtract the exponent. the formula is on that side. I just highlighted. So we subtract 1/2 minus 1 to x to the negative 1/2. And it is negative, so I can also write that at the bottom. And the formula is this one. So our negative exponent, we bring it down and becomes the formulas on that side. Negative exponent, we bring it down, become positive. They will come handy later, but for now we have 5 infinity 1/2. Infinity 1/2 is square root of infinity, is still infinity, so we have 3 divided by infinity, which is 0. So it is equal to 0. Nice number, so we make it equal to 0. Right. The highest power matters. When we combine them, we subtract the exponent. This happened to be negative, so we move that to the bottom. Otherwise, we'll keep that on the top. Right, so that was 11. And the fact here is very important. Now we use the same way. Now this x goes to negative infinity. Once again, we'll take the one with the highest power, the 4x cubed, and the negative 5x squared. Notice that the term will be including, we'll have the whatever the sign in front of it. So for x cubed minus 5x squared right. Of course, we can cancel the x cubed and x squared. We have an x on the top, but now just do the numbers. 4 divided by negative 5, negative 4/5. X cubed over x squared is x. Or we use the formula. That one. We just subtract the exponent. 3 minus 2 is 1. We can write that on the top as well. Anyway, now x goes to negative infinity. Negative times negative is positive. Make that equal to. Right, so that would be the limit. And that was 13. Right. Next we have the asymptotes. The asymptote we have the vertical asymptote and the horizontal asymptote. The horizontal asymptote is similar to what we've been doing. I mean, the limit at infinity. We do 14 first, and then we get back to 10. However, 10 looks simple. Anyway, so we find the limit of the function where x goes to infinity and then negative infinity. Once again, we take the one with the highest power, x squared negative x to the 4th. And we will have, it's going to be negative. X squared will be at the bottom. Cancel the x squared, we have x squared at the bottom. Now we put infinity into it. Now it doesn't matter if it is positive or negative. We have finite divided by infinity is going to be equal to 0. That will be equal to 0. We should do the same thing for the limit when x goes to negative infinity. of the function. The same thing would happen up to this step. I'll just dot 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 and equal to x go to negative infinity. And doesn't matter if it is by positive or negative infinity, that's still 0. So y equal to 0 is the horizontal asymptote. So we just take the limit, and whatever the limit equal to, make that equal to y, because y equal to a constant is a horizontal line, horizontal asymptote in this case. So that was 14. Now we go back to 10. Although 10 is too simple, still do that anyway. So 14. Right, 10. The vertical asymptote. Let me write out what we need. For the vertical asymptote, we will make the bottom equal to 0, but the top is not. So that is the vertical asymptote. Now the bottom equal to 0. We have x plus 4 equal to 0. So x equal to negative 4. And then we check at x equal to negative 4, the top equal to 3 times negative 4, which is not equal to 0, which is good. So the bottom equal to 0 at x equal to negative 4, and the top is not equal to 0. So yes, that is a vertical asymptote, x equal to negative 4, which is this one. So bottom is 0, top is not, that is the vertical asymptote. Horizontal asymptote is just the limit of the function when x goes to infinity or negative infinity. So that was 10. Find the values for continuity. Sorry, I forgot to put this on the review. Anyway, the question will be like this. I'll just make up one quickly. So we have a piecewise function. Alright. Yeah, for problem like that. So we just need to make sure the function is continuous at 1. So we need three things. The limit exists, the function is defined, and equal. So, but we need to check for the limit exists. So pretty much we find the limit of the function when go to 1 from the left, and from the left meaning it's less than negative 1. So we'll use this one. And then we find the limit when x go to 1, but from the right. If it goes from the right, it's bigger than 1, and we use this function. And so we put 1 in for x. I mean -1. Right, now the limit must exist. So in that case, these two must be equal, because from the left side and the right side, the limits must be equal. So we have 1 plus k equal to -1, and so k is equal to 2. Right, so of course we still probably will need to show that it is continuous or not, but in terms of to find k for it is continuous and it has equal sign, so we know the function is defined when x equal to 1. So all we need is make sure the limit exists in this case, and so the left side limit and the right side limit are equal, and we solve for k. That is that. I forgot to put this in on the review, so we don't have any problem for that, but we cover that topic. And once again, what's that? Intermediate value theorem. Will be 16. And the theorem says that just do this problem real quick. So we evaluate the function at 4 and 5. So the quickest way to do this is, let me show the calculator. We're doing 16, by the way. So we're going to have to move this. Yes, it's better. Right. So this is what I do. So we need to take 4 and hit the store key. The store key here. We store 4 into x. Now the x value is equal to 4, and we just enter the function 2x cubed minus 7x squared minus 9x plus 4, because we store 4 into x already. Now we hit enter. That is -16. So we have, if this is the function, we have f of x, f of 4 equal to -16. Now we do f of 5. So to do that, we hit 5 and we store into x. And then we just need to hit second, enter, second, enter, like copy and paste, if you will. Now that is going to be 34. So we do the sketch real quick. From 4 to 5, it will go from -16 to a +34 at 5. So if we have to draw the continuous function, it is continuous because it is a polynomial. We have to cut it at some point in the middle. So because they have the opposite sign, there must be 0 in between. You have to go through 0 in between. So we say all we need to show is that they have opposite sign. Opposite signs. Alright, so that's 16. Right. Number 17. Prove the limit statement. In order to do this, we need to know the limit, the definition of limit. So I just write, because there will be a lot of other things, but the main thing we need is for every epsilon that is positive, there exists a delta is also positive, such that the function will get close to L whenever x get close to A. So in which case we say the limit when x goes to A of the function equal to L. So that is the definition of the limit of the function when x goes to A that is equal to L. So yeah. And to do the proof, there will be two parts. The first one is just the scratch or the scratch word, and then the second part is the proof itself. This is where we start with. To start with, we just write this f of x minus L less than epsilon, and we're supposed to end up with x minus A less than delta. Alright, now we start. The function is 5x minus 1 minus 4 less than epsilon. We simplify, that will be 5x minus 5, and we can factor out the 5, and this is positive, so we just have 5 outside like that, and divide by 5 on both sides. We have x minus 5 less than epsilon divided by 5. Now we see that these two are similar. From here we can say that A is equal to 5, but more importantly, choose, or we say let delta equal to epsilon divided by 5. Right. So that's what we start with. Now we go with the proof. The proof, we have to start with the statement. We say for every epsilon greater than 0, there exists or we should not say there exists. We said we choose delta to be epsilon divided by 5, and then we go from this, we go back, we write this in reverse. So we start with x minus 5 less than epsilon over 5, less than epsilon over 5, and we go back step by step. And we have 5x minus 1 and so this will be f of x, and that is L. So we said for every epsilon greater than 0, we choose delta to be that, and so we have this. So we will have the limit of the function when x goes to 1 of the function 5x minus 1 equal to 4. So the actual proof will be this. We really don't need this, but we cannot find delta without doing this. So the proof itself is only this, but we kind of need that as well. Right, so that is the limit by definition. Average rate of change. This will be straightforward. We have the formula on that side. Right, that. Average rate of change with that formula. So this is the function. So will be just square root of, just write f of 8 minus f of 2 over a minus 2. So square root of 2 times 8 minus square root of 2 times 2 over 6. 16, we have 16 minus 2, so pretty much we have 2 over 6, which is 1/3. So just like that. So once again, average rate of change is that. Right. Next we have the definition of limit, and that is definition of derivative, to find derivative using definition. Right, so that was 18. Right. This is definition of the limit. Sorry. Definition of derivative using the limit. Right, so we start with that. H goes to 0. Right. First we have this. Yeah, the colors. Yeah. Alright, so we do that. Pretty much we put x plus h into x, all of the x, including the x squared. We have x plus h squared plus 4 x plus h. So let's do this first. Now it's multiplied out. X squared plus hx plus another hx plus h squared the 2hx, but it will be negative. And then we have f of x is the original function. Right. So we're going to have all of this. And the function. So negative x squared, negative 2hx, negative h squared, 4x, 4h minus a negative, make that a plus, minus 4x over h. Now what we see is this x squared and x squared cancel out because usually everything that doesn't have an h we got cancelled out. So those two will stay because they have h. The 4x doesn't. So now we have negative 2hx minus h squared plus 4h over h. Now all of them have h. I'll factor out an h. We have negative 2x, negative h plus 4 over h. So the step that we cancel everything without an h, and the second step is we cancel with the h at the bottom. Now we put 0 in for h. Just have negative 2x plus 4, and that is the derivative of the function. 20 and 21, I think I did some of this in class already, so we're not going to do that again. The note is posted on eCampus, so you can go and check out the note for that. It will be in section 2.7. Sorry, 3.1. So that is the definition of derivative with the limit. So we have that. Next, we'll do that later. Next, we find the derivative using the power rule, and the power rule is too fundamental, so we're not gonna have that in the formula on that side. So derivative of x to the n power is n x to the n minus 1. So that is the power rule. So 23, we just apply the rule. We have derivative equal to, the numbers still stay the same. For the x to the negative 2, it's going to be negative 2 x negative 2 subtract 1, so that is the derivative. And then we have plus 7 derivative of x cubed will be 3 x squared, and then we have the plus 1 derivative of x, be just 1. So that will be negative 26 x to the negative 3, 21 x squared, and then 1. Yeah, just like that. So the power rule is pretty simple, but we need to have everything as a power of x. If we don't have that, we have to use the property of exponent on that side. So this we have to rewrite the function. Square root of x is going to be x to the 1/2. Notice we haven't do anything yet. Now we move all of them up, and when we do that, I'll change the sign of the exponent. Right. Now we take derivative. Right. I'll just do derivative of each individual terms here. Derivative of that is negative 1/2 x to the negative 1/2 minus 1. Derivative of this is negative 1 x to the negative 1 minus 1, and that negative 4 x to the negative 4 minus 1. Notice that the 4 in front of it still stay, the minus 8 here is still there, and the plus 7 is still there. So we take the derivative of all the powers, and then all the constants in front will stay, and we have that will be negative 2 x to the negative 3/2 plus 8 x to the negative 2 minus 24 x to the negative 5. Yeah, we're going to just leave it like that. Of course, we can rewrite this as the move it down and then change to exponent, positive exponent, but we don't. And then write that as the radical square root form, but don't need that. Right, on number 25 I will not finish, but this is what we need. We split the top, and now we rewrite the function x over square root of x square of x is x to the 1/2, so we have x to the negative 1/2, actually positive because we subtract the power. By default 1 minus 1 half is positive 1 half, and then plus 7. X to 1 half, bring it up, becomes x to the negative 1 half. Now we'll take derivative. Is 1 half x to the 1 half minus 1, and derivative negative 1 half x to the negative 1 half minus 1. The plus 7 still stay, and that is the derivative. And of course we simplify this, but that should be easy. Right. Yeah. So that is derivative using the power rule. The power rule is this, but in order to use power rule we have to write x to some power in order to use the power rule. If it is the square root or divide by x or anything like that, we have to write as the power of x, and then we can use the power rule. Right. The last topic is the equation of tangent line. So that will be 22. So for this one, we do not need to use the definition of derivative. We just use the power rule or whatever the rule is. Equation of tangent line is that. So let me write out. Is y minus the values of the function at the point equal to derivative at that point. Right. So in this we have a point, this point, which will be x1 is negative 1, and y1, all the values of the function at x1 is negative 2. So this is going to be negative 2, this is going to be negative 1. We just need to know the derivative. The function is x minus x squared, so f of x equal to x minus x squared. So the derivative, the power rule will be just 1 minus 2x, and then we evaluate at x equal to negative 1. So it's going to be 3. And the equation of the tangent line. Now we know the point x is negative 1, derivative is 3, so this is going to be 3, 1, actually negative 1, y minus the values of the function negative 2. So notice that in this everything is constant except for this x and that y, everything else is a constant. So we simplify. Multiply it out and move the 2 over. We have y equal to 3x plus 1. So that is 22 With that, we cover all the topics for the first test. And yeah, the first test doesn't have much, just most of them limit and sum of derivative. Right. So I hope this help you to prepare for the first test. Thanks for watching.